Hi, my name is Brian, and I am the creator of a Sudoku puzzle that I called the Soused Snake, and I uploaded it to Logic Masters Germany at the end of June, thinking that it would be an interesting challenge for some of the really good puzzle solvers that are there. That site has some experts at tackling anything you throw at them. I was a little surprised when it only got 2 initial solvers in the first 3 or 4 days. But I looked back at the list of puzzles, and I noticed that I uploaded it on the same day that 7 or 8 other puzzles were uploaded after it. And so my thought was that it just got bumped down the list really fast and people didn't notice it. And then the 2 people that solved it reported back that it was brutal, that they found it very, very difficult to slog through, which surprised me a little because I'm really a novice logician in terms of, when I watch people like Simon on Cracking the Cryptic on YouTube, it is mind-boggling to me how he can spot these outrageous solutions to these Sudoku puzzles. And so to have this puzzle be such a stumper was surprising to me, including the feedback that both of these initial solvers, the 2 people who gave me feedback, 2 out of 3 now, reported that the snake's path wasn't all that much help. And so I've decided to go ahead and create this solve. It's not really a solve because I know several of the steps in advance, but it's more of a demo. But I'm going to go ahead and do that, and it will function as a solve for anybody who has not tried this puzzle but is interested, which, by the way, if you are, there's a link in the description here on YouTube. And just see if that helps anybody go, oh, okay, so this is not an attempt to call anyone an idiot for overlooking something. It's just to say, okay, here's what I had in mind. See if this illuminates what you did not experience the first time, and we'll see how that goes. In a moment, I will get into the puzzle itself, and I will have times on your screen for where you can skip to in the video if you want to skip the preamble and get right to the puzzle or any particular part. I will say that what you're about to watch is kind of a mix between things I remember and things I don't remember, because I created and tested the puzzle probably about 2 weeks before I uploaded it. I let it incubate. I had other puzzles that I wanted to upload and let them get a certain amount of attention without pushing them out of sight really fast. So I held on to it. So it's been about 3 weeks since I sat down and solved this thing. So I won't remember every step I took. I will have to remind myself of certain things, and I will edit this thing down. So if there are any long pauses while I have stumped myself, those will be chopped out. So not to create the impression that I am just a whiz at this, and and can just plow right through it. And I'm not a puzzle setter. I know that it's the question of if somebody's in one movie, does that make them an actor? I didn't learn until March of this year, at the age of 45, that the world of Sudoku had become so fascinating, way beyond what you get in the morning newspaper, the ordinary Sudoku or the classic Sudoku. And so I've been having fun trying stuff out, but strategies and the manipulation of numbers is beyond me. When I create a puzzle, I get an idea in my head on the rule set, and then all I do is flood the grid with 81 digits. I make sure that those digits comply with Sudoku rules, and then I apply the rule set and I say, okay, how does it look? Is it solvable? And that's what I did with the Soused Snake. So I say that to say that what I'm about to show you is not stuff that I preconceived. It's stuff that I discovered for myself. When I stripped away the numbers and looked at the puzzle I created, then I had to go really from scratch. Okay, now what do I do? And so everything I'm about to show you, I had to discover as I solved it myself to prove that it could be solved. All right, now let's take a look at the rules themselves. What is the Soused Snake? It's based on a snake puzzle. I've seen several online where the numbers on the grid tell you where the snake is going. A snake leaves the Viper's Den pub late one night. He starts by traveling orthogonally and heading directly south from the front steps, the down arrow at the top of column 5. The number on that square indicates how many squares he travels, after which he must turn and travel the number of squares indicated at each new turning point. So far, so good. So standard snake puzzle says that if there's a 1, then the snake is going to travel 1 square in north, south, east, west, orthogonally. And then when he reaches the next square, he must take a right-hand turn and travel the number of digits in that square. So that's what inspired me to do this, but I did take it a step further. This snake has had a little too much to drink. When he tries to turn, in his stupor, he switches from traveling orthogonally to traveling diagonally. After he has traveled the given number of squares, he then switches back to traveling orthogonally, and so on back and forth. So he's traveling orthogonally, north, south, east, west. When he hits a turning point, now he has to travel diagonally in the number of squares given. And when he's hit and when he's traveled that far and he's hit the new turning point, then he's back to orthogonally and back and forth until he reaches a point where he can travel directly north the number of squares needed to land him at his lair, the up arrow at the top of column 4, which, being next door to the pub, would have been so easy if he had just been sober. Unlike most other snakes, this hammered fellow can cross his own path, touch or border squares previously used, and make a turn on a square also used for a line of travel. What he cannot do is travel along the same square twice or make more than one turn in any square. And the feedback I got from the first 2 people to solve it was that there was a lot to remember and think about as they were solving it, which is one of the reasons they found it hard. So let me simplify. Basically, the snake cannot do the same thing twice on any 2 squares. So if he's traveling along a row, he cannot travel that same orientation. If it's horizontal, he can't travel horizontal through that square again. If it's vertical, he can't travel vertically through that square again. If there's a square that he turns on, he can't come at it from another angle later and turn on it again. Okay, that's out. I contemplated making that happen, and I even had a path where that worked, but it was a little complicated to make it to make the clues get you to solve it. So I gave that up. So yeah, he can't do the same thing twice in any one square. But he can travel through a square, come back around it, and it actually be a turning point from another direction. That's possible as well. All right. Side numbers indicate how many squares in that row or column the snake uses in his inebriated excursion. The squares with the 2 arrows are counted as part of the snake's path. So up at the top there, the start and the stop are part of the snake's path, and that will be important here in just a moment. Cages on the grid must not repeat any digits and must add up to the total in the upper left corner, so that's standard killer cage rules. Now, every turn the snake makes is within a cage, and each cage contains exactly 1 such turning point. All right, so every time the snake reaches the end of a line of travel and has to turn, that square will be in a cage. If there's a blank, if it's a square that's not in a cage, it cannot be a turning point. And each cage will only do that once. All right, those are the basic rules. If you want to try the puzzle, I would be honored. I'd love to get a rating on this. You have to get a certain amount of feedback before it will actually show your score. And I don't care what the score is. I don't care if everybody hates it or loves it. I would just like to see what the score is. So I would encourage people to go try it. And what I'm going to do now is just give you a few starter tips. If you pause this and you go look at it and you go, I don't even know where to begin, holy cow, it really is as hard as those other 2 guys said. Here's a couple of starter tips for you. If you want to start it cold, pause now and go try it. All right, now the starter tips. There is quite a lot you can do to figure out the snake's path even before you try to place any numbers. And that's where I would start, actually, because the snake's path is going to reveal at least 3 numbers very early on. If you know the path first, or as much of the path as you can know, then your first 3 numbers are actually going to be fairly simple. And then look at the cages and find the 4 or 5 cages where the numbers have to be certain things. Not that you'll know where they must go within the cages, but you'll know, oh, that cage can only have this, this, and that number. I think there are 5 that are like that. So find those. Those will help immensely in getting especially some of your early digits. All right. I will say be prepared to do what Simon on Cracking the Cryptic calls geography, where you know that the total of a certain area, the total of a row, or the total of a 3 by 3 block has to be 45. What does that tell you about the cages in it and what they add up to? What does that tell you about the numbers outside the cages? There are a few spots in here where that is very helpful. I don't know if it's necessary, but it's very helpful. I will say one of the solvers that offered feedback said he did the whole thing without paying attention to the snake because he got lost, not lost, he just couldn't figure out early on how the snake rules were any help. He solved the whole thing just by cages, and he said it was a grind. So it can be done. But yeah, if you solve as much of the snake as you can, look for the cages that are restricted, and look for the geography that helps reveal some things, I think you'll get a little bit of a boost there. Now, let's go through it, and I will be paying attention specifically to some of the things that were offered as feedback as to why they had a hard time solving them. See if I can help illuminate how it helped me figure it out when I first solved it. Again, I don't remember exactly how I first solved it, but I can kind of clue you in to some of the things. And again, it's been 3 weeks, so some of this I am actually going to have to rethink and go, what did I do next? And I'm going to have to find it again. All right, I'm now prepared to solve, so this is your last chance to pause it if you want to try it for yourself. Here we go. And I do remember the first thing I noticed, and I noticed even as I was creating the puzzle, there's a 9 in row 9, and that means that all 9 of those squares have to be part of the snake's travel. And complementing that is the 1 in column 9, which means that only that square in the bottom right corner is part of the travel. The other 8 squares are not. That may quickly think you've hit a dead end with solving any more for the snake, but look at row 8. It has a 2. Now that means that the snake goes into row 9 once, goes all the way across, and comes out again. It spends no more time in row 2. It cannot, for example, come down row 1 and go up, or down column 1 and go up column 4, and then down again column 5 to finish the snake's path and come out again down there at column 9. It can't do that because that would be too many snake squares in row 8. It comes down through row 8 once, goes all the way through, and comes out again. Now, it's easy enough to see over here in columns 8 and 9 because of the square that is not snake. The only way the snake can get in or out of that far corner is that square right there. Now, at the other end, can he get in or out in column 1 or 2? I mean, how does that have to work? Well, if he came down column 1 into row 9, when he turned, he'd have to turn diagonal. And he would have to go out that way, and that leaves a whole bunch of other squares. Even if he came in, I just about repeated myself. All right, so he can't do that. But what if he's headed to the left across row 9 and he hits column 1? Then when he turns out, it has to be diagonal. So the only way in or out of row 9 over here on the left side is this square right here. That fills in our 2. All the rest are not snake. We don't know at this point if, say, for example, he's traveling left and he gets to column 1 and there's a 1 in that corner. He could turn diagonally up to row 8, and that would be a new turning point, and now he could head north. Or maybe it's not a 1 in the corner, maybe it's a 2 or 3 and he keeps going diagonally. We don't know yet. We don't know his story there. Just because of the fact that the snake has to cover all of row 9 in one trip, you also don't have a turning point in, say, column 3. He can't be coming along, hit that, and exit diagonally. And I will further, if you doubt me, I'll further rule those out here in just a few minutes. But anyway, we can know that much so far about the snake. That also means that column 1 is now complete because there are only 8 squares available to be the 8 squares of the snake. Same thing for column 4, and I will fill in the other triangle here in column 5. That means that row 1 is done, and the rest of the squares are not snake. And then what we've got is a situation here in column 1, very much like row 9. How does the snake get into or out of row 1, column 1? It has to involve this diagonal. And I'll leave it right there and say for now we don't know anything else, but it has to involve that diagonal. All right, down here in row 7, column 1, because of the not snake square, in row 8, we've created another corner. How does he get into or out of that corner? You could say he has a couple ways. I mean, what if he travels left directly into it, or if he travels down directly into it? Either way, he has to exit diagonally, or he could enter diagonally and exit in one of those two orthogonal directions. But no matter how you look at it, he's going to use that square, and that means column 2 is now done as well. Those are the big ones we can get. We can get a couple more here real quick. There is a 32 cage in the upper right corner. 4 of the 5 squares are not snake. We do know that every cage has to have a turning point. So the snake has to pass through and has to actually turn on this square right here, so we know that's snake. And then this little cage 11 in block 6, 2 of its 3 squares are not snake. It has to have a turning point. That has to be snake as well. And I'll go ahead and mark those turning points there. In fact, let's mark all the turning points. So we know those 2. That's specifically why they're there. We know the corners have to be turning points, and so we've got 4 of those. And I think that settles it for now. So we've got the 6 turning points. We've got, well, probably a third of the grid figured out in terms of what is or isn't snake. And I think now, if I recall, this is a good time to turn to the numbers. Let's warm up the geography aspect that I mentioned in the helpful hints. If you look over here at block 6, we know that every 3 by 3 block is going to add up to 45. 1 plus 2 plus 3, etc. is 45. But the cages add up to 48. So what we need is a digit that is in one of those 2 cages, but outside of the 3 by 3 block. And that has to be a 3 right here, because that's the extra value between 45 and 48. The difference is 3. We need to get that 3 out of the square, but in a cage. So there's our 3. That's our gimme. That's our easy digit. I first turned my attention then to that bottom row, because I felt like that was going to be the easiest place to start figuring out where the snake traveled. Let's start with the cages themselves. I'm going to have to do some marking here. All right, the 6 cage in the bottom left, that has to be a 1, 2, or 3. We know that. 1, 2, and 3 have to be those digits. Those are locked in. We also have, just while we're going across in order, this 15 cage. Both 15 cages have to be 1, 2, 3, 4, and 5. And there are some things we could do right now, but I just want to keep going right across the bottom, and then we'll get back to it. The 23 cage has to be a 9, an 8, and a 6. There's no other way to get 23 in 3 digits. Now, over there on the bottom right, we know that that turning point cannot be a 9. Why? Because whether you came into that square orthogonally or you came in diagonally and you have to exit again, a 9 would send you off the grid. None of the turning points on this grid ever can have a 9. And so that 9 is out. All right. Now take a look at what we've got here. Again, we've already figured out, and I actually spent, I think, 15 to 20 minutes just trying every possible configuration when I first tried it. I just said, I don't want to make a mistake here. Is this absolutely true? And I will tell you that it is absolutely true that that snake has to enter row 9, travel the entire length, and exit again. Now, between the 1, 2, and 3 on the left and the 6 and the 8 on the right, there is only one square and one number that can get us all the way across the bottom, and that's an 8 in that square right there. So we can get rid of the 8 from the others. We're left with a 6, 9 pair. Now let's go all the way over to the other side. So we know that at least along the bottom, the snake is traveling right to left. So when it hits the 1, 2, 3, it's going to turn diagonally and exit. And here's the part where the snake's path and the rule about turns comes into play. So I hope this is informative to the gentleman who said he didn't understand how this would be helpful. Look at that 1, 2, and 3. We know that it's going to turn diagonally and head out. Could it be a 1? No, it cannot. The 28 cage already has a turning point. So if it's a 1, then the snake travels one square and now has to turn again. That's 2 turning points in the same cage. So that's not acceptable. Could it be a 2? No, same problem. That 28 cage is shaped in such a way that the snake cannot stop there, or that would be 2 turning points in one cage. So it has to be, the only other number left for that cage itself is a 3. That means we can fill in the snake up to there, and that means that this is another turning point. All right. We can now take the 3 out. Let's go ahead and go back to numbers now. We can take the 3 out. That leaves us a 1-2 pair, and we can get rid of the 1, the 2, and the 3 here in the same square with it, and we can get rid of the 3 across the bottom. We can quickly throw in a 7 because there's only one square where it can possibly go. Everything else, I've already listed what can go in there, so the 7 cannot. 7 has to go right there in column 6. Another easy one to get through the geography is the bottom right square, the cube, the bottom block. That's the word I want. The bottom right block. It has an 18 and a 23, all contained. That adds up to 41. We're missing 4. That has to be a 1 and a 3, and they have to be outside the cages. So they go right here. We get a nice 1-3 pair. And then if you want inside those cages, I know Simon on Cracking the Cryptic taught me never just try to avoid making your grid messy. But this is kind of the way I have to think. 2, 4, 5, and 7 belong in there. Okay. We can do something similar over in block 7. The 2 cages that we know of add up to 34. That means we need 11 outside the cages. And we already know that in column 3 there, we have a 4 and a 5. So 4 or a 5. And so those have to be counterparted then with either a 7, 7 and 4 is 11, or 5 and 6. That means our 9 in that block is in the cage, and so is the 8. We know that the 9 cannot go on a turning point because it doesn't have room. You can't travel 9 and still be on the grid. If you want to get a head start here, we know the 8 can't be there either. If you leave that square headed north, you can't go far enough. If you head up right, northeast, you can't go far enough. Directly to the right, we've already identified, is not a snake square, and then down right, you can't go far enough. So it can't be an 8 either. We'll figure out what that is later. Now, having filled in some turning points and identified a little bit of the path, let's go back and really hammer on this question that I posed earlier, this thought earlier. Could the snake in any universe travel somehow out of that 4-5 square diagonally? Is there any other way, is there any other place along that bottom row where there could be a turn at all? Obviously, it can't be in block 2, columns 4, 5, and 6, because it just can't turn diagonally. It can't get out of there. You could conceivably turn diagonally in other places, but ultimately, no, you can't, because then you'd be stuck traveling through the bottom a second time, which is against the rules. You'd break every rule, no matter how you tried it. So that rules out turning points. In that 15 cage, it rules out turning points all across the bottom, rules out the one in row 8 because the snake doesn't even go there. So the other turning point now, or the turning point available for that 15 cage, is right there at the top. Now take a look at what that means. In column 4, we have a turning point in row 7, so we can't have one in row 8 or row 9. They're all in the same cage. And we have a turning point in column 4 in row 6, and it belongs to a cage that covers row 6, row 5, row 4, row 3, and row 2. And then you have the arrow at the top. And we know from the rules that the snake exits by heading directly north and landing on that triangle. All right. We have ruled out everything else. Those are the only possible turning points in that column. Those are the only 2 places where it could possibly start heading north, or head north to that triangle. And we know from the 15 cage that 5 is the highest number we can put there, and it is not high enough. We are left with one option, and that is a 5 right there. We know it came out of the bottom row on the 3. It traveled up to that square. It now turns orthogonally, heads directly north, and lands on the triangle. So we have a 5, a 3, a 3, a 7, and an 8. And we are making progress. I can take the 5s out of this column. And while we're there, I know when I first solved this, I did not figure this out until later, but you have this 32 cage, take away the 5, you have 27, and you have to get 27 in 4. There are only 2 ways to do that. That's a 9 and an 8 and a 7 and a 3. I'm sorry, there aren't only 2 ways to... No, there are, yeah. I'm going to make sure I'm expressing it right. An 8, a 9, a 7, and a 3 would be 27. But you can't use the 3 because in the 15 cage, the 3 is stuck in one of those 2 positions. So the 3 is ruled out of any other square in that column, in column 4. The other one is 8, 9, 6, and 4. So let's go ahead and fill that in. That's the only other way that you can get the 27. 8, 9, 6, and 4, or 4, 6, 8, and 9 in that column. That means the 4 is up there. It has to be, so we can take the 4 out of here. We now have a 1, 2 pair across row 9. We can take the 1 and the 2 out of here. So we have a 1 and 2 pair, we have a 4, 5 pair, and we have a 6, 9 pair. So we basically have placed all our possibilities for row 9. Good and solid. And since we're here, again, these are things I came to a lot later when I first solved it, but let's put a 7 down there. That's the only... It has to be in that column in block 5, which, by the way, puts a 7 way up at the top of column 4, which, if the first time I had solved it, I had noticed that sooner, would have simplified things a lot sooner for me. Let's take a look at block 3, upper right-hand corner. We have a 15 cage. I'm going to fill in my digits there. Again, that's just the way I think. It looks messy to other people, but it just helps me see things my way. Now that leaves a 6, 7, 8, and 9 up here, and rather than fill them all in all the way, I'll just say that leaves only one place for the 7. That has to go there. That's something, because I solved it in a different order my very first time when I was trying to prove it, I didn't notice for a long time. Okay, but we now have a 6, 8, 9 triple across the top, and let's go ahead and let's get rid of, while we're doing pencil marks, let's get rid of the 1 and the 3 in column 9 because of the 1, 3 pair down below. Okay, now that 6, 8, and 9 adds up to 23, and we have to go from 23 to a total of 32. So over here in column 6, these last 2 squares have to total 9. 1 and 8 is... I'm trying to remember now. I feel like I ruled some things out a lot sooner than this, and I'm not seeing them. Well, it can't be an 8. That's it. It can't be an 8 because there's already an 8 in the 32 cage. 1 and 8, 2 and 7, no, because there's a 7 in the block. 3 and 6, no, there's a 6 in the cage. So it has to be 4 and 5. There we go. Slowly remembering the things that I learned long ago. Because that has to be a 4 and a 5, we can't have a 4 over here in the 32 cage. It has to be down in the second or block 5, and that means in block 8 down below the 4 has to be in one of those. Let's do a little more filling in of things that we can be fairly certain of. Let's look at the upper left corner again, that turning corner in row 1, column 1. No matter which way it exits, let's figure out what we can do. We can't do a 1, because if it heads south, if it heads down, it ends up in row 2 at the top of the 42 cage, and it would then need to turn diagonally, and it cannot turn diagonally. It cannot exit that row diagonally in either direction. If it were headed out down right, then that would produce the second turning point in the same cage, and that's against the rules. So that can't be a 1. By the same logic, it cannot be a 2. If it headed down, it would then have to turn diagonally. Could it go up right? No, because then as far as it can go is a 1, and that would make a second turning point. If we exit that turning point, can we go 2 diagonally? No, because then again we'd have a second turning point. So that has to be at least a 3, but it can't be a 3 because there's already 3 in the column. So it has to be 4, 5, 6, 7, or 8. And the turning point in row 7, column 1 cannot be a 1, 2, or 3 because those are all locked in that same box. Can it be a 4? If it exits diagonally, yes, it can. Can it be a 5 if it exits diagonally? Yes. Can it be a 6 if it exits directly north? If we try to go upright diagonally and we go 6, we run into a square that we know the snake is not in. But it can be a 6 if it is exiting north. So that is limited to a 4, 5, and 6. And a couple of little things while I'm thinking about them. This 42 cage is 8 squares. And so the number that has to be outside of it is a 3, which means in this cage, the 3 is there, or in this block, the 3 is there. I think that's all we can tell there, because up in block 1, there are just so many squares that are not in the 42 cage. We have a lot of options there right now. And we can take 7s out of there because there's a 7 in the column. That means the 7s are accounted for in column 8, so the 7 in column 9 has to be in one of those 3 in block 6. We can put a 3 here in column 5 because it's already in column 6 and column 4 further down. All right, and then we actually can figure out where to put the 5. And here's how we can do that. This 37 cage here that starts in the middle and heads down is 7 squares, so it's missing 2, and those 2 have to, the 2 digits that we exclude from that cage have to add up to 8. We know that it cannot be a 3 because in box 5 the 3 is outside the cage, so it can't be in those 4 squares in box 5. And we also know that the 3 has to be in the 15 cage in column 4 in box 8. So the 3 in both instances is not in the 37, so we're down to 42. In order to get from 42 to 37, the other digit has to be a 5. So the 5 cannot be in that cage either. And that means since we have a 5 locked into column 6 up here in block 2, we have a 5 in column 4 in box 5. The only place for it to go then is down here at the bottom of column 5. That, by the way, puts a 4 over here. It puts a 7 over there. It eliminates the 4 from this 28 cage. And we can get back to that, but it does mean that 8 plus 9 over there is 17. We still need 11. So it's going to be a 5-6 pair in that cage. It's 8, 9, 5, and 6 in that 28 cage. And right now, since there's a whole lot of elbow room there for where the 5 and 6 can go, I'm not going to worry about filling them in just yet. Just makes my it's really hard. What you're watching may look easy. It took me hours. I know it will take me hours. The way I have to edit these things. I wish I had a nice on-camera live setup like a lot of YouTube vloggers do. Okay, now this is where I got stumped. This is where, if I were to agree for a moment with these other gentlemen that this puzzle was brutal, and of course they found it even more brutal because they didn't rely on the snake, this is the point. I think I had, at this point, nailed down everything I thought I could nail down, and I kept hunting, and I went back and forth at what can I add up? What can I rule out? And you may even spot something. Obviously, the gentleman that solved it without even using the snake spotted something, using just the cages. But I was stumped. And so if I had not watched Simon and Mark on Cracking the Cryptic for about 3 months before creating this puzzle, I wouldn't have known what to do. There would have come a point where I've said, okay, I can't solve this, so I can't publish it. But I came across something because I've seen Simon do this, and we've done it a little bit already when we figured out where to place that first 3 because of the 37 and 11. And we figured out where to place the 7 and the 4 and the 4 and the 5 because of adding up things and finding out what can be excluded and how. I, in desperation, really, tried something. I said, okay, I have now in this entire block down the middle, columns 4, 5, and 6, top to bottom, form this block. And nothing in that block, well, very little in that block, goes outside of it. We don't have cages where there's a lot of mystery as to how much should be in that section and how much should be out of that section. In fact, because we have a locked-in 4 or 5 pair, because we have a locked-in 1, 2, 3 down below, we really know the presence of every digit here except for 3 of them. There are 3 squares that are currently in total limbo. And that's the top of column 5, and then going down column 6, we have the 3rd square down and the 8th square down. What goes in there? And that could have been a lot of trial and error, except that I was able to reduce it. And I was able to reduce it by doing the math. The total of all of those numbers in columns 4, 5, and 6 is 135. Now, if we take away, or add up, however you want to do it, add up what we know. Let's start with the cages that are entirely self-contained there. We have a 32, we have a 14, we have a 15, and we have a 37. I'm going to do subtraction. 135 minus the 32 cage, minus the 14 cage, minus the 37 cage, minus the 15 cage. Great. We also know that there's a 7 at the top of column 4. We know there's a 9 pair over there at the top of column 6. We don't know where the 4 and the 5 go, but we know it's a 4 and a 5, so we can minus 9 more. And we know that at the bottom of column 6, there is a 7. Okay, I almost just led you astray. I did the math, and I knew something was wrong. I knew from previous experience something was wrong. Couldn't lay my finger on it. So let's back up. Same premise, but I have to go a lot more carefully. Because the 15 cage does extend outside of that. All right, 135 minus the 32 cage is entirely contained in this column, the 14 cage is entirely contained, and the 37 cage. Now after that, we have to be more careful. The 15 cage sticks outside, but we know that the number outside that block is a 4. So we're not minusing 15, we're minusing 11. Those are the numbers left inside this column, this large, thick column that we're working with. Okay. Whew. I almost ruined that. All right, now we have a 7 at the top, a 4 and a 5 definitely, so another 9. We have that 3 there in column 6, and we have the 7 at the bottom of the column, leaving us 15. So the 3 unaccounted for squares total 15. So what are our options? I'm going to follow my usual style and start at the top. That can be a 1, 2, or 3. Can it be a 4 or a 5? Can it be a 6 because of the 32 cage? Row 1. Can it be a 7 because that's in the block? Can it be an 8? Can it be a 9? So that's limited to a 1, 2, or 3. All right, let's go down to the bottom now. The one at the bottom, I think, was the most helpful for filling in. 1, 2, or 3, no. 4, no. 5, no. Could be a 6. 7, no. It could be an 8. And it could be a 9. All right. And then, now we do need to fill in this one. Let's see if I remember how this goes. It could be a 1, 2, or 3. No, it can't be a 3. Can't be a 4, can't be a 5. Could be a 6. Cannot be a 7. Could be an 8. Could be a 9. If I did this right. Okay. Now, again, it has to total 15. Let's see if I remember what I did next. I mean, I know what I did was I started ruling them out, but now I have to figure out how I did. Well, if we start with the 9 down below, it can't be 9 plus 9 plus anything. Not that would put 2 9s in the same column, and it would be way over 15. Can't be 9 plus 8, that's 17. Can't be 9 plus 6, that's 15. And we still have to take account for the 1, 2, or 3 up top. So the 9 cannot go with 9, 8, or 6. Can it go with the 2? 9 plus 2 is 11. Plus 3 is 14. Those are the greatest possibilities there. So after we rule out the 6, 8, and 9, in the middle as a possibility to match with the 9. The highest we can get is 14, and we have to get to 15. So down here, I can get rid of the 9. That 9 is impossible. All right, now let's ask if the other 9 is possible. Well, if we had a 9 in this middle option, that would be 9 plus at least a 6 down below that's already 15. So in neither square can we do a 9. All right, now we've got a 6 and an 8 down below, and I think it gets easier after this. If I did 8 plus either 1 or 2 in the middle, then we wouldn't get high enough. And if we did a 6, it certainly wouldn't get high enough. So what that means, since the 1, 2, or 3 up top are mandatory, it does mean that the 1 and the 2 in this square are not only not mandatory, they are impossible. Because if we use either one of those, we just and everything else is the greatest possible number, we don't even reach 15. So we have a 6-8 pair now, leading up to a 1, 2, or 3. Now this, I found this, I almost missed this. I almost missed this until I actually laid out an array of numbers of possibilities, and I discovered this. If we do an 8 down below, that rules out the 8 up above. So we have an 8 and a 6. And the only way to go from 14, 8 and 6, 14 to 15 is with a 1. Okay, what if we did a 6 down below? We would be left with an 8 and a 1. And that means both of those combinations leave us with a 1 right here. That has to be 1. Now we haven't figured out the 6 and 8, but we know we've got a 1 right there. Okay, which leaves us, now we have a 1 in column 5. We know where the 1 is in column 4. That means the 1 has to be here in column 6. And believe it or not, that is going to become an incredible breakthrough. That is where I was absolutely stumped. But I didn't want to guess. I've watched Cracking the Cryptic enough to know that the good Sudoku solvers don't like guessing. They want logical proof. So I was able to logically prove to myself that that had to be a 1 to satisfy the math of that 4, 5, 6 column block. And this slipped my attention earlier, but because of the 6, 8, 9 pair, we can get rid of an 8 over there, and we can get rid of a 6 over there. And now we also have a 7 in row 1, so we can get rid of the 7 over there, which means we are left with a 4, 5 pair, 4, 5 pair, a 6, 8, 9 triple, a 1, and a 7. So this has to be, this has to be a 2, 3 pair. Now look at what that means for our turning point in row 1, column 1. If the snake enters from the diagonal, if it's headed up left into that corner and then has to turn orthogonally and go straight downward, neither the 4 or the 5 gets it to the other turning point. Could it possibly travel 4 and stop and turn right there? Could it turn diagonally and head out? So that in row 5, column 1, could that be a 2 or a 1? Well, let's take a look. Well, first of all, we know it. Let's just rule out the 5 right now. It couldn't be a 5 because then you'd have to turn diagonally, and both of our diagonals are blocked. So let's go back to the 4 now, and let's really explore this. Can we rule out the 4? If we stop there and it has to turn diagonally, it can only go down right. If it's a 1, we end up with 2 turning spots in the 42 cage. If it's a 2, we end up with 2 turning spots in the 28 cage, and it cannot go 3. So the 4 is also not an option. Now, what that means is the snake is traveling north. It's traveling up from the turning point in row 7, and the only way it can get all the way up there is with a 6. So that's a 6, and it gets all the way up to that turning point. Is there anything else we can rule out at that point? No, not yet. Okay, so I've got the 6. And now things are a bit more simplified down here. This has to be a 5, 8, 9 triple, so I'm going to go ahead and put that one in. And then if we go back to this middle section and explore a little bit, the 2 cannot go in row 1 or row 2 or row 3 or row 8 or row 9. So where can it go? Can it go in row 6? No, it can't, because the 2 has to be somewhere in the 15 cage. It has to be in that column. So we can narrow the 2 down to here. That means we have a 1-2 pair, a 6-8 pair, and a 4-5 pair, so the 9 has to go there. That takes the 9 out of these 2 spots and means the 9 has to go there. Now we have a 5-8 pair, which means we can take the 5 out of this over here. 1, 2, 3. We can look along row 7 and we can place another 7. It can't go in the first block, it can't go in the second block, and in the third block it can't go in column 7, and column 9 is already filled with the 1-3 pair, so the 7 goes right there. Take the 7 out of that. Okay, and then the 2 in column 4 is already placed, the 2 in column 6 is already placed, and so we have to put our 2 up here. We now have a 2-3 pair. And those are both in the 14 cage, so that means this has to be a 9 in the bottom of it. Now that means we can get rid of these 9s here. And reverting back to Snake's path a little bit, we do know from that upper left, I should have done this when I first narrowed it down, and when we first figured out that that 6 is going straight up, it hits the 4-5. Whether it's a 4 or a 5, we can get Snake's path that far. And, idiot that I am, the moment we got a 1 in that central triangle, we have a bit more snake that we can do quite successfully. It's a 1, so the snake is traveling south. We know that from the instructions. We're given that. So he travels 1 straight down. That makes that not only part of the path, but also a turning point. So the snake now has to turn diagonal and travel 2 or 3. That's what we've narrowed that down to. Let's go down left. If it travels 2, it ends up in a square that is not in a cage. And if it travels 3, it ends up in a square that we've ruled out as being part of the snake. So it has to travel down right, which means we know that at least this much is snake. Does it go all the way down to that turning point we know of? I can't prove that right now, so I'm not going to. I can't prove or disprove it, but now we know the snake goes at least that far. And actually, there is one more thing we can prove right now. Let's look at this square in the very center. That's going to help us out here in a moment. It cannot be a 1 or a 2 because of the 1-2 pair. It cannot be a 3. It cannot be a 4 because of the 4 in column 5 down below it. So it has to be a 5 or higher. Let's see, it cannot be a 5. It has to be a 6 or higher. 6, 7, or 8, in fact. I'll just pencil that in while we're here. But here's what that means. If we go back to that 4-5 in the upper left corner and we travel 4, the question becomes, could that be a turning point for the snake? Could that be a 4 in the upper left corner leading it to that square? And the problem is all we have in there is 6, 7, and 8. From the central square, no matter what direction that snake travels, a 6, 7, or 8 will send it off the grid. So no, it cannot be a 4 in that corner. Has to be a 5. That rules out the 5 over here. We now have our 4 and our 5, which gives us a 5 there as well. And I think that's a good bit of advancement there, although we can take out our pencil marks over there. And that also means that our next turning point is right here on the 3, the first digit we were able to place. So it's going to travel 3 orthogonally from there. And we can actually already rule that out. Can it travel north? 1, 2, 3. No, it ends up in that 6-8 square, which is not in a cage. It cannot travel to the right. It ends up in a square we know is not a snake. It cannot travel south, or it crosses a square we know is not a snake. It has to travel to the left. That means this is snake, and this is our next turning point, whatever it may be. It also means we've found the turning point in cage 42, so if there were any doubts about any other space in column 1 being a turning point, that has now been ruled out. All 4 of those cages now have a turning point within them. The identification of that 3 as a turning point means now this whole 37 cage is ruled out for having any other turning points. So let's go back to our 2, 3 here in the top of column 5. If it were a 2, it would land in that 37 cage and force us to have a second turning point. So that's not an option. That has to be a 3. That has to be a 2. We can now take the 3 out of there, and we can take the 2 out of that entire row, that cage there. And I am reaching a point where I am back to almost like it's my first time solve. I'm a little stumped. I just noticed if we run the snake backwards, we have the 6 leading up to the 5, leading down right to the 3. But how did we get to the 6? Something had to come from the upright. It couldn't be a 1 here because that would be 2 turns. It can't be a 2 from here because that's not in a cage. It can't be a 3, that's not even an option, but it would also be a second turning point. Can't be a 4 because we already know that's a 2. It has to be that 5. So let's fill in these snake squares. We know that to be true. Okay, and then now we have in row, nope, sorry, I jumped the gun. Jumped the gun. 1, 2, 3, 4, 5. We do have column 3 confirmed for the number of snake squares, so we know that those are not. And we do know that row 6 is confirmed. Those 3 squares are not snake squares. Now that does severely reduce the number of options in this second turning point. We go from the 1 to the 3, we go down right to this square. We know it's a turning point, but we don't know what's in it. It has to travel orthogonally now, and its only options are straight up or straight to the left. So let's see. Could it be a 1? No, because that would put a turning point in the a second turning point in the 37 cage. Can it be a 2? Conceivably. It could be a 2. I will mark that. Could it be a 3? It could if we go north. If we go left, again, we go to that middle square where the 6, 7, and 8 reside. So it could be if we go north. Could it be a 4? Not if we go north. 1, 2, 3. And not to the left because that one already has a turning point in that cage. 5 is unacceptable because that's not in a cage at all. So it's a 2 or a 3. Everything else, and then anything greater than that runs either off the grid or into a square that is not snake. So we have a 2 or a 3 there. Oh, and yes, it's staring right at me. Okay, row 5. When did that happen? I don't know, but it's now completely filled in. I think I was looking too fast or something. We have our 5 snake squares. So our 2, 3 has to travel north. Has to. So we know that if nothing else, this is snake and this is snake. Okay, I think what I want now is this turning point in row 6 that isn't claimed yet. We already know that we've come down left from this 5, up from the 6, down right to the 3, and we've confirmed that the only direction the 3 can travel is to the left. That's how we got that turning point identified. What number can go in there? Well, first of all, it can't even go up left or down left. It could go up right, in theory. Let's see. Could it be a 1? No, that lands us in a cage already claimed. Could it be a 2? No, it lands us on a 9. And even though we haven't claimed the cage there, or claimed the turning point in that 37 cage, it can't stop on a 9. A 9 shuttles us off. Can it go 3? No, that's not a turning cage. Can it go 4? That's not a turning point. It's not in a cage. And 5 is a square that the snake does not go. So it has to go down right, and it can only go one space, which leads us to our next turning point. So now that turning point is traveling orthogonally. We already know it doesn't go up. The 5 covers the 5 there covers the exit, the last 5 squares until we get to the up arrow. Left, no matter where you go left, it would end us up in a cage that's already been claimed with a turning point. Can't go straight down. So can it turn to the right? I mean, it has to turn to the right. Now, how far can it go? Can it go 1? Oh, it still can. It cannot go 2. We can get the 2 out of there. And it can go 3. Whatever happens, we know that this is snake right here, which means we can finish column 5. We have all of our snake squares identified, and so we know that that 9 is not a snake at all. I almost feel like I was actually better at this when I first tested it. I am stumping myself. I know there's something. And it's almost harder now because I do know where a couple more digits go. I know them for a fact, but I have to prove it to you. Oh, and there's something. Okay, row 7. We have a 5-8 pair, we have a 1-3 pair, and we have a 2-4 that's identified. So we need a place to put the 1, 2. Well, where can we put the 2? The 2 cannot go in column 5, and it can't go anywhere else. All the other squares are claimed, so it has to go in this one right here. Now we can take the 2 out of there. We're left with a 4-5 pair. That 4-5 pair means the 4 in box 8 has to go right here. And we can take away that pencil mark. Of course, I also used a lot more pencil marks when I solved it myself. I'm trying to keep this thing lighter on the graphics, but I'm going to go ahead and fill them in because I'm drawing a total blank. 6, 7, and 8, 6, 7, and 8. Those are the digits that we still need in this 37 cage, the one that can't have the 3 and the 5, and I need a 6, 7, or 8 down here, but it can't be the 7, so that's a 6, 8, which gets us a 6, 8 pair, which doesn't help a darn thing. But now that we have the 4 placed in column 5, let's look back at our 1, 3 turning point. It has to be a 1 or a 3. If it's a 1, it stops on that 4 and now has to travel diagonally. Up left, can't go 4. Up right, can't go 4. Can't go down at all. And so it cannot be a 1. That has to be a 3. That takes our snake all the way over to here. That makes that another turning point. And since it has to be diagonal, it's looking really good. Can't be upright. Up left would land it in the center, our 6, 7, 8, where it can't go. Can't go down left. So that 2 is what takes us down to the 8. And while we're here, that gives us all of our snake spaces for row 7. So we now have it from this 5. We can confirm 5 down to the 6, up to the 5, down to the 3, over left to the 1, down right to the 3, over to the 2, down to the 8, to the 3, to the 5, and out. We haven't gotten all of the snake's path yet, but we're pretty darn close. Now that we have that 3, we can disambiguate our 1, 3 pair from the very beginning, which takes, I've got pencil marks all over that I can get rid of. We have a 1, 2 pair there. We have 1, 2 pairs running all over the place, but that's as far as we can go on the bottom section. Let's look at this big 37 cage in the middle. Where can the turning point go? We know it's not the 6, 8 down here. That's not snake at all. We already ruled out this square where the 4 is. The 4 just can't go anywhere. It can't go, even if another part of the snake were to land there and have it turn orthogonally, it can't get out. All right, so it's not that. The 6, 7, and 8, both of these actually are too big. They send you off the grid, no matter which direction you head. So the only space left is this 1, 2 over here. Let me make that a turning point. Doesn't help us a lot yet, but that's our turning point for that. I think, do we have all the turning points now? No. Our 15 cage up here still needs its turning point. We can confirm row 3. We can confirm all of the snake spaces in row 3. And we can confirm column 8. And we can confirm column 7. Okay, that does it, because now in column 8 we have this corner snake space. It has to be a turning point. If you get into that, there's no whether you come in from it diagonally or you come in from straight down, you have to turn. You have to turn there. So that's our I think that's our last turning point, which means that this 2, 3 down here has to be a 3, has to travel all the way up to that. And we should be able to figure out what that is now. Can it be a 1? No, that lands it in its own cage. It can be a 2 and a 4. That it can't be a 4 because that 5 is already claimed. And you cannot turn twice in the same square. So that has to be a 2, which leads us. So now we have the snake's entire. Oh no, one more. So where can that 1, 2 go? Can't go if it's a 1. It has to. We went diagonal, so now we're traveling orthogonally. If it's a 1, it can't go left, it can't go down, can't go right. That's 2 turning places in the 37, and it can't go up because that's not even a turning spot. So it has to be a 2. And so that 2 takes us up to the 5, yes. So we now have the snake's entire path. The 1 to the 3 to the 3 to the 2 to the 2 to the 5 to the 6 to the 5 to the 3 to the 1 to 3 to 2 to 8 to the 3 to the 5 and out again. Okay, we have the snake's entire path. We can place a 3 now in box 3 because we've ruled out every other possibility. And now we can place a 1. We've ruled out every possibility. Oh, and then we have to do a 1 here, which means we know where a 1 goes in box 6. That can't be a 2 anymore in box 3, so that has to be a 4, which means that has to be a 5. We got 4, 4. Well, we can pencil mark a 4 over here. Not sure yet. Now in this 11 cage, we have a 3 already. The other 2 have to total 8. Cannot be 1 and 7. Could it be 2 and 6? Yes, it could. But it cannot be 3 and 5. So in fact, it has to be 2 and 6, which puts the 7 up here. We can get rid of the 6 in the upper right-hand pencil mark. Okay, but I can create a 7-4 pair over here. 7 and a 4 are ruled out of every other square except those 2. 1, 2, 3, 4, 5. That gives us the option of a 6 here. 7, 8, or 9. So we have a 6, 8, 9 triple. Another one. We can get rid of this 3 pencil mark, which incidentally creates a small X-wing with the 3s. I remember noticing that before, but I don't think it helps me a lot at this point. Okay, that's right. That's where this 42 cage really starts to be important now. And let's start with the 1. It already has a 1 in it, and it covers all this territory up into into block 1. So now if we look at block 1, between Sudoku and the cages, it sees everything except that space right there, which that disambiguates our 1-2 pair down in the 6 cage, which gets rid of that 1 and that 2. Okay, which helps us spot this 2 and this 3. There's the 3. Get rid of that pencil mark. And our 3s are done. So are our 1s. Not yet on the 2s. Almost. We do know that a 2 goes here, one of these 2 spots in box 4. I've kind of switched between calling them block and box. I hope you know what I mean. I hope I've been clear with the visuals. We just ruled out a 1 being in the 42 cage because it already had one. Now we have to place a 5 in it. And if you look, the 5 in column 1 rules out everything there. The 5 in row 6 rules out everything there. The 5 has to go here, which over in box 6 puts the 5 right here, disambiguates this 4-5 pair. And now, I knew this happened somewhere in here, and I think we're finally up to it, or at least we're close enough that we can go ahead and use it, even if there are other things we could do. Now we have to do in columns 1, 2, and 3 what we did in columns 4, 5, and 6. We have to add them all up and do some math there. So once again, those 3 columns are going to add up to 135. Let's go ahead and subtract what we know. We know there's a 28 cage and a 42 cage and a 28 cage down below and a 6 cage. And all 4 of those are neatly contained in that column. Now we also have an 11 accounted for, and a 2 and a 3, so 5 more. We're left with 15 and only 2 squares completely unaccounted for. So that has to be an 8 and a 7, which it cannot be because of the 7, or a 9 and a 6. So we have a 9-6 pair right there. That means here in box 1, that cannot be a 9 or a 6. That has to be an 8, which means over here we have to have a 6, here we have to have a 9, here we have to have an 8. We're left with a 4-6 pair down there. Because that's a 4-6 pair, that has to be a 7-8 pair. Because that's a 7-8 pair, this has to be a 6, and this has to be an 8. Oh, and then we do have the 5-8 pair down here gets fixed, I guess is the term. In this 28 cage in box 1, we're left with 2 squares that have to total 11. They cannot be 9 and 2. They cannot be 8 and 3. They have to be 4 and 7, right? Can't be 5 and 6 either. All right, so 4 and 7, which means 1, 2, 3. What digit am I missing? 4, 5, 6. 6 has to go right there. Means that has to be a 9. Which means up here in this box, that cannot be a 9, that has to be a 6. This has to be the 9 over here. We are just about there. That has to be the 6 and 4. I say just about there, and suddenly I see we still have quite a few spaces here. Okay. We still have to get a 7 in this 42 cage. Its only 2 choices are there, so we have a 2-7 pair, which gives me an 8 right there, which I could have done anyway because the whole rest of the row is empty. What are we missing from the 37? 3, 4. I need a 4. That has to go right there. 5 is in it. 6 is already assigned. I need an 8. Oh, 8 could still go either place. 9, however, has to go there. So 8 goes back up in row 5. The 8 fixes the 7, and the 7 fixes the 2, and the 7, which then fixes the 6 and the 2. So now up top, it's just a matter of figuring out what's been claimed already. Actually, down below, the 9 makes that a 6, makes that a 9. We now have an 8 and a 9 in column 7, so that has to be a 6. We have a 9 and a 6 in column 8, and we already have an 8 in column 9, so that makes that a 9. And there you go. That is how, I won't say that's how you solve, I'll say that's how I solved the soused snake using the cages and the snake path and the rules about turning in cages and other such things. Let me know if that was helpful, if you've already solved it, if that was illuminating, if that had you going, now I get it. Just let me know how that worked out for you. I don't plan to do this often. I do not have an easy way to put those graphics up, but thank you for watching this one. Have a great day.